Geometry students, in this video we are going to be taking a look at the properties of parallelograms. That's right, we're going to be learning about what makes parallelograms a special type of quadrilateral. Let's get started. There are actually 4 different properties of parallelograms you need to know. Number 1, you need to know that the opposite angles, regardless of which set of opposite angles you're looking at, there's 2 sets, opposite angles are congruent. We can also say that consecutive angles that are right next to each other are supplementary. So if we add the measures of these 2 angles together, we'll get 180. These 2 angles, we get 180. These 2 angles, we get 180, or these 2 angles. And then we can also say that the opposite sides are congruent. The opposite sides have the same measure. And then finally, we need to think, this is a little more complicated, we need to think about the diagonals, the lines that are connecting opposite vertices from each other to each other. Those lines will bisect each other. So there's no special relationship in the angles or anything. I mean, because they are lines that intersect, they're going to have all the special relationships in the angles that any intersecting line has. The adjacent angles will be linear pairs, and the opposite angles will be vertical angles. Other than that, the important thing to know is that they bisect each other, so they cross at each other's midpoint. All right. So what I'm going to do is I'm going to show you an image in GeoGebra of a parallelogram that I'm just going to be manipulating a bit. I want you to watch what happens to the measures of the opposite angles, the measures of consecutive angles, how they'll add to 180, and then also pay attention to the lengths of each half of the diagonals, how the diagonals cross each other at their midpoints. They bisect each other. And while you're watching that, I'm just going to play for you some sweet whipped cream ASMR. So you should have noticed that all of the parts of a parallelogram followed the rules described. These are the 4 properties of a parallelogram that you need to be familiar with. All right, let's do some practice problems involving parallelograms. Our practice problems are just going to relate back to these properties of parallelograms. So lesson practice A, find the value of y in this parallelogram. What are we going to need to do to find the value of y? I know that these opposite sides have to be congruent to one another. So that means that if I set this up as an equation, 4y minus 10 has to equal 2y plus 5. I'm just going to do some algebra magic here, subtracting 2y from both sides, adding 10 to both sides, getting y on a side by itself, and I find that y equals 7.5. Letter B, find the values of x and z. Okay, so here again, opposite sides are congruent, but I need to make sure that I'm using the correct sets of opposite sides. In this case, the sides that contain an x are opposite sides, so I know that I can set these 2 expressions equal to each other, 5x minus 3, 4x plus 2. When I solve that, I get x equals 5. And then these 2 sides are opposite, the sides with z's in them. So I can set 2z plus 4 equal to 3z minus 2. And when I solve that, I end up with z equal to 6. You can go ahead and check my work here and see that I did these step by step and solve for the correct values. And let's just double check my values to make sure I actually answered correctly here. There we go. Next, I need to find the values of x and y in the parallelogram HIJK. Here, I know that opposite angles are congruent, but I can't use that because the opposite angles have different variables. So instead, I'm going to have to use the property that consecutive angles are supplementary. So here's what that one's going to look like. I am going to add together my 2 x expressions and note that they equal 180 degrees. I'm going to simplify 20x equals 180, or x equals 9. Same thing with the y expressions on the bottom. Those are consecutive angles. So when I add them together, they equal 180 degrees. I get this when I simplify. I need to add 29 to both sides and then divide both sides by 19. I end up with y equal to 11. All right, letter D is a different kind of question. This asks me to prove property 4 of parallelograms. And I'm just going to do this out loud by talking this through using this image up here. So let's zoom in on this image. So we have to prove that if a quadrilateral is a parallelogram, then its diagonals bisect each other. Well, okay, what are some things that I know about this parallelogram? I know that side NQ is parallel to side OP, and I know that they're congruent to each other. I also know that QP is congruent to NO. It would be really helpful if I could also prove that there were some angle congruences. Well, thankfully, every parallelogram with its diagonals is two parallel lines that are being intersected by transversals. The diagonals are transversals of parallel lines. So let's see. I know that NQE and EOP are alternate interior angles by the alternate interior angle definition, and I know that they're congruent by the alternate interior angle theorem. I can say the same of OPN and QNP. Those angles are also congruent by the alternate interior angle theorem, and they're alternate interior angles by that definition. Okay, so my proof looks like this so far. NQ is congruent to OP. QNP is congruent to NPO, and then NQO is congruent to QOP. Now notice what I have here. I have an angle congruent to an angle, a side congruent to a side, an angle congruent to another angle. So I can say that triangle ENQ is congruent to triangle EPO. And then by CPCTC, corresponding parts of congruent triangles are congruent, I can say that QE is congruent to EO. Hey, that's one of the things I had to prove. And NE is congruent to EP because they're corresponding parts of congruent triangles. Bam! That's how we would do our proof for property 4. And then finally, letter E, an old fence gauge shown here is starting to lean. Find each measure. KM is the whole diagonal. KO is half of a diagonal. All right, well, I know that if this is a diagonal and this is a diagonal, they bisect each other. So it has to be true that half of the diagonal equals the other half. 3x equals negative x plus 6. I'm going to add x to both sides. I end up with 4x equals 6. Divide both sides by 4. I get x equals 6 over 4, which simplifies to 3 over 2. So Km, this whole length here, is going to be 2 times 1 of the halves. 3 times 3 over 2 is pretty easy to calculate. It's just going to be 9 over 2. But I have to add that to itself. So it's actually going to be 18 over 2, or 9. Km equals 9. Ko is half of that. It's just simply 9 over 2. Let's just double check. Km equals 9. Ko equals 9 over 2, which is 4.5. And that is how we work with parallelograms. You are now ready to do the practice problems for this lesson.